So, check this out. What we've been doing is we've been working on quadratics, right? And what you've learned so far is you've learned how to multiply two things together. Like, you've learned how to FOIL this sucker and make him a quadratic, right? So there's two ways you can look at a quadratic. There's two forms that we've got. And my computer's not responding with a big circle. All right, there we go. There's two forms of what we got. We can either look at this thing as x minus 2, x plus 4, right? That's one form. Or we can make it look like a quadratic and we'll FOIL this out. Let's try that. I'm just showing you guys what I'm doing right now is I'm just kind of recapping the whole thing. Got it? So x minus 2, x plus 4, if I want to FOIL that, how do you do that again? Do you guys remember? First, so that would be x times x, so it would be x squared. What else?
X times 4.
X times 4, which is plus 4x. Inner, negative 2x. And last, minus 8. Cool? So this is actually x squared plus 2x minus 8. So this, you can easily identify as a quadratic formula. Can you guys see? Can you guys even come close to seeing? Is it too small? Alright. Cool. I'm sorry I don't have the big setup. If next week, Wednesday, if we get a lot of people in, just let me know. Email me and say, hey, I'm coming in. And it's not that you can't come in if you don't email me. I just want to know, so I want to know if I should. Alright. So next week, Wednesday, you guys are all going to be here? Alright, then I'll set up the big setup early on. I'll ask the teachers, whatever. Alright. So check this out. One way to look at this equation is you can look at it like that, in that form, with it all put together. And that's x squared, blah, blah, blah. Another way you can look at it is in this form. And those mean the same thing, right? Those are the same thing, they just look a little different. It's like Brandy looks the same, she just wears different clothes, hopefully.
Do I wear different clothes?
You kind of, well, after you shower. Like every week at least. Right? So, I think you shower every week.
Yeah.
I mean, I'm not.
I think that's a safe estimate.
I think it's a little weird for a teacher to ask like your showering habits, but I would assume that it's at least a week between you when you last showered, because I can't smell you from here.
Just once.
All right. Anyways, let's go on. So we have two ways to look at this quadratic equation, right? And there's actually going to be a third way, and I'm going to show it to you. In fact, actually, the third way kind of looks like this: y equals ax plus, or no, it's x minus h squared plus k. And you guys are like, I've never seen that one before, right? Have you seen that before? Well, you kind of have, because we covered like the last two chapters kind of doing this stuff. But I didn't put h's and k's in there, I put actual numbers in there. And then when I put numbers in there, like let's say k equals 3. Look at what the equation is and look at what happens if k equals 3. What would you say this parabola does? It goes up 3, right? This is what we're talking about, moving it up, moving it down, right? What does a do? I mean, we're recapping the whole thing. So a does what? That number in front of the x, that the stuff that's being squared. If that's let's say it's a negative number, what happens to the parabola? Flips. We got a flip parabola. If it's a giant number like 5, or at least a number bigger than 1, then it stretches vertically or gets skinny. But it's the same thing. Stretches vertically, gets skinny. If it's a 1/2 kind of deal, right? If it's a fraction,
Wider.
then it gets just compressed or wider.
It's really just easier to think of it as skinny and wide instead of stretched and compressed.
You like thinking of skinny and wide versus stretching and compressed? All right, that's fine. That's fine. I don't really care. I mean, it doesn't make a difference to me. But to me, if you're talking about something like multiplying by 5, I would think, okay, that stretches it out. If you're talking about multiplying by a fraction, I would think compresses it down, and that's why it gets wider. You know what I mean? Anyway, whatever way works for you, because Raimana is constantly thinking about gummy bears. You're like Steve from Cloudy with a Chance of Meatballs.
I've never seen that movie either.
Really?
They look terrible.
How sad. How sad for you. I have the first one. I'll let you borrow it.
They look terrible.
All right. I'll let you borrow it. You'll understand. Anyway. So we looked at a quadratic equation. like this one right here, where we had to FOIL it. We looked at a quadratic equation like this one right here, and we looked at a quadratic equation like this one. And they're all the same. You can just change the numbers around to make them put them in these three forms. And we found out how this form is very, very useful to us, right? Because we talk about, okay, that graph can go up, that graph can go down, that graph gets skinny, that one gets fat, this one goes upside down, and we even talk about how it moves right and left. Beyond that, you can't really do much more to a problem. Like, that's it. That's pretty much all you can do to it. Unless you would want to turn it sideways, and that's a totally different topic that I don't think we're even going to get into. Or you can turn it at an angle, and I don't even know how to do that. Actually, I do, but I mean, it's not even like something that you want to worry about. So as far as what you will see, I would say almost up until like the end of Algebra 2, that's all you're going to do to that problem. It's going to go up, down, right, left, you know, flip, squeeze, widen. We cool with that?
Yep.
All right, good. I'm not gonna move on. I'm not gonna go from that. Now, what I'm gonna do is I'm gonna show you how we talked about in the last week. We started talking about how this equation right here is very useful for us as well. And this equation is very useful when we want to find the zeros. And what I mean by the zeros is we want to solve the quadratic equation. We want to see where it crosses the x-axis. So we want to see where y is equal to 0 or f of x is equal to 0. So what we do is we say, all right, if we want to find the zeros, we say x minus 2 times x plus 4 equals to y, but then we set y equal to 0. And that's what we do, right? And do you guys know how to solve this problem out? It's telling me that something times something equals 0. So I do two things. Do you guys remember? This was from Friday. Last week. Did the Super Bowl just kind of like wash your brains out? There we go. Diamond's got it.
Because the Seahawks won and it was wonderful.
Diamond's basically saying what you do is you say, all right, if something times something equals 0, then either the first something is equal to 0 or the second something is equal to 0. Right? And then you say, all right, fine, x equals 2 and x equals negative 4. And then you plot those, so 2 and negative 4. And look, if I had a parabola, it would probably look something like this, or it would look something like this. We cool? Which way do you think it will go anyway? I'm just curious. Do you think it's going to open up like this, or do you think it's going to open down? Just from your intuition. You think it's going to open up? What?
Is this a guessing question?
Nah, this is kind of not really a guessing question. It's kind of a, like you can look at it and say, I can see it. I'll give you a hint. Here's my hint. Look at this form. It's the same thing as this equation, but look at this form. It has x squared plus 2x minus 8. And I haven't shown you anything really useful with that thing. But look at the sign, the SIGN, in front of the x squared. Is it positive or negative? It's positive. And so if it's positive, that would kind of imply to me that that a in front of the x squared, if I were able to get it into this form, which you don't know how to do yet, and you will. I'm going to teach you that later. But if I were able to get into that form, it would kind of tell me that that a in front of the x squared is a positive number. So therefore, it would open up or down? Up. And I would agree with that. But there's one way we can definitely check. And that's to find where the vertex is. Because remember, the vertex is the pointy part of the parabola. The part where it's like the highest or the lowest. Depending on how it opens, of course. So, let's try figuring that out. How do I figure out the point where the vertex is? Do you guys remember how to do this?
You take the 2 points and find the medium.
Ah, there we go. I take the 2 points where it crosses, and I know that the vertex, wherever it crosses, is going to cross in the middle of those 2 points. So how do I figure out where the middle is? Ah, Thomas is already saying -1. You can kind of look at the graph and tell it's -1. Or, more mathematically speaking, you could say 2 plus -4 divided by 2 And that's basically taking the average, right? You're adding the two numbers up and you're dividing by the number of numbers that you added. And then that's equal to -1. And then so what we can do is take -1 and plug him in here. And so that becomes, let's see, -1 minus 2 is -3, right? And -1 times 4 is, or plus 4 is 3. So my answer is -9. So I would put a point right here at -1 comma -9. Do you guys get it? Am I speaking crazy or does this make sense? And then if I were to draw my parabola, I would bet it looks something like this. Which we guessed that it would open up, so that's a good thing. Are we cool? Like this is, do you guys remember this? This is all like review. Everything we did was review. Yeah? Good, then I don't really think we're going to learn anything new today. It's all going to be review. I know, it's pretty cool. In fact, all I'm going to do is basically do a lot of your homework stuff. But anyway, let's talk about this. All right.
I have a
If I have this equation right here, f times x equals a times x minus r times x minus s. This is the general form of what we're talking about, right? The intercepts, where are the intercepts? The intercepts are at r and s. Because the intercepts, the x-intercepts is when y equals 0, right? All right, let's see the next point, because this is a good summary. In fact, this is a summary of pretty much what we summarized. The y-intercept is at a times r times s. Okay. How did they get that? I got it. I figured it out. If you have this right here, and you want to figure out what the y-intercept is right off the bat, I mean, I'm not a big fan of memorizing equations. Do you guys understand it when I talk to you guys about it? Yes? Yes, online? I'm particularly looking at you guys online because I can see them going like this. All right. Yes, you understand. So if you understand it there, then memorize it that way. But if you want an equation to figure out what the y-intercept is, I'll tell you. If I were to multiply all of this out, I would have a times the first outer inner last. So that would be x squared minus sx plus, or no, I'm sorry, minus rx plus r times s. Are we cool? Now I'm going to multiply into a, and I've got ax squared minus asx minus arx plus ars. Are we cool? You don't really understand what I'm doing, or are you guys good? All I did was
It's just hard to understand without numbers.
Yeah, all right, fine. But I mean, I just multiplied everything out. What they're saying here is that where would this parabola cross? And the answer is, or how far would you push this parabola up and down? And the answer is
ARS.
that stuff at the end, ARS. Right? Because that's the plus whatever at the end. So that's where they're getting this equation from. 0, ARS. But to be honest with you, I wouldn't memorize that equation. I wouldn't be like, oh, I got this equation. If you're down with equations, then do it. But if not, but I didn't even know that before. I was looking at it, I was like, I've never seen that in my life. But I get it. I understand what they're trying to say. You know? Okay, fine, whatever. I don't like memorizing equations because what if I get it wrong? All right, how do you find the vertex? Well, it's halfway in between R and S. I get that. How do you find it? You take the average. Good, we're good. The y-coordinate of the vertex is, the y-coordinate of the vertex can be found by evaluating blah, blah, blah. If A is big, then the parabola opens up. If A is smaller than 0 or negative, then the parabola opens down. If A is smaller than 1, then it gets wider. And if A is bigger than 1, the parabola gets thinner. Those are the rules. And you know what? I wouldn't even memorize these. Like, according to rule C, this is the thing, blah, 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 blah. I just know about parabolas. I'm just kind of like, I understand them. I get you. I can connect with you. I don't have to ask what the fox says. Because I understand it. I get it. Right? I'm a lot less confused than what the fox says video. Yes, I started the recording. So what I said was on the recording. I know. It sounds weird, but whatever. Alright, are you guys cool with this? Anyway, those are the boring rules. Let's do this one. What is the where does this parabola? See this parabola right here? Where does it cross? You tell me. What are the x-intercepts? This is your homework. I'm doing like the blue ones are your homework, and the red ones are the one I'm doing. Where does it cross? Net positive 2 and positive 2. I totally agree. Or positive 1 and positive 2. Right there and right there. Alright? Where does it cross the y-axis? The x-intercept is positive 1 comma positive 2. The y-intercept is what? Oh, it's easy. It's 2. How'd you get that, Mr. Balde? Because if this were R and this were S and there's no A in front of there, well, A is 1, I guess, then R times S is negative 1 times negative 2, which is positive 2. There, I used the formula. Booyah. You like that? Yeah, that's it. That's all you have to do. Cool? Boom. All right. So if I were to graph the parabola, probably looks something like that. I'm assuming. First, I'll draw it out a little bit more for you. There we go. Let's find the vertex, just to make sure that we're on the right track here. Where's the axis of symmetry? Where's this thing symmetric about? You guys understand what I'm asking here? 1.5. How'd you get that, Brandy? Because what's in the number between 1 and 2? 1.5? Psh. Yeah, do that. Do that for me. Psh. Psh. You can psh. Yeah, anyway. All right, anyway, ready? Then what you do is you go 1.5 minus 1 times 1.5 minus 2. All right, so this is what? 0.5 times 1.5 minus 2, which is negative 0.5. And so this times this would be negative 0.25. Does that look like it could be correct? Negative 1/4. So it's over at positive 1.5 comma negative 0.25. Yeah, all right, fine. Yeah, we're good. I mean, if it were a positive number, I'd be afraid, right? Because your vertex can't be up here. That would be, hey, wait a second, we did something wrong. So it's a negative number, I'm happy with that. And if it were negative 10, I'd be like, that doesn't look like it was good with my parabola. You know what I mean? So at least I know I'm in the right ballpark. We cool? Alright, we're cool. That's it. That's how you graph that sucker. What else do I have for you? I've got a lot of homework for you. Oh, here we go. So, let's see. Alright, I'll tell you what. Let's do this one real quick. You guys ready? Where's the vertexes? Where's the vertices? Leong brothers. You guys are so quiet, I'm going to ask you straight off the bat. Where are the vertices on this parabola? Let me go find somebody else who doesn't answer very much. Yeah. I know you know the answer. I want to hear it from the Leong boys. Even though the other dudes are putting it in the chat already. Hint it's in the chat bar.
Negative 3.1.
Negative 3.1. Alright, fine. Did you read it from the chat or did you understand it?
Oh, no. Yeah.
What? Yes, no. Yet. Well, I asked you 2 questions yet. You told me yes.
Yes.
Wait, did you read it in the chat?
No, I did not.
Or do you understand what?
Yes.
Okay, yes, you got it. Alright, good. Alright, just making sure. All right, I'm done picking on you guys. All right, cool. Negative 3 comma 1. Perfect. Exactly. Awesome. Where does this thing cross the y-axis? And I'm going to let anyone answer. Where does it cross the y-axis? Mitch says what?
-2.
-2. I say no. I say, you know what the fox says? No.
It's not what the fox says.
All right. What else? -4. Thomas says 4. I say you are absolutely correct. -1. Adriana saying -3. Adriana is the closest. By far, but still wrong, actually.
-2.5.
Not -2.5. No.
-4?
Why are you guys saying negative?
Because you said she was the closest.
No, okay, all right. Diamond's getting close.
it.
Adriana got it. Exactly.
It's a negative.
Well, look at this. Look at this. What is A in this equation? A is -1. What is R? Actually, R is -3, and S is +1. Do you guys understand that? Because the equation is A x minus R x minus S. But that doesn't really matter, because when you multiply them out, it's going to be the same. So, -1 times -3 times +1 is actually +3. So it's here. That's the y-intercept. That's using this new equation that I told you don't memorize. But it's alright, fine. You didn't memorize it. Good job, Adriana. You killed it. That's exactly it.
It actually should be 1 to the left.
So, what do you mean what should be 1 to the left?
The axis of symmetry is on -1.
Okay, yeah, here's my question is, that's the axis, that's the y-intercept. What is the axis of symmetry on this? You guys can just tell me straight up. -1, because it's halfway in between there. So the y-intercept is something different from the axis of symmetry. The axis of symmetry is where this thing gets cut in half. Now, if I plug in -1 into this equation, so I have, instead of q of x, I have q of -1. That's going to equal to -1 plus 3 is is 2, right? And -1 minus 1 is -2. So this becomes 2 times, that's 4, -4, but then I have another negative, so it's +4. So this is where my graph crosses, and I would say that the parabola probably looks something like that. Actually, it looks a lot better than what I drew it. I'm sorry. It looks something like that. Oh gosh. There we go. Are we cool? Yes? No? Maybe so? You got it? Alright. How do I make the thumbs up symbol on here? I don't know. There is a button for thumbs up, right?
No, there's a button for raise hand.
Okay.
That's good enough.
Fine. Alright. Alright, I'll tell you what. Ooh, here's a good one.
I don't like when you say here's a good one.
No, well, you know what? This is your
Say
homework.
this is terrible and easy for you.
No. Alright, fine. Here, I'll tell you what. This is straight up your homework, right here. This is your homework.
Write it down.
Page, or you got to do the stations. If you guys were in class, I would have you guys break up into small little groups and give you a station and go to your station and work with your group and all that kind of stuff. But instead, since you can't work in groups, we're gonna straight up just do it. And you know what I'll do is there's 6 problems from this homework assignment. I'll do 2 of them for you in class. All right, and I think this might be a good one for me to start off with. Cool? So write this down, take notes, because I'm doing your homework for you, suckers. All right. What are the intercepts? Look at it. It's a little bit different from how we're used to. Here's the equation right here. What are the intercepts?
Let's say +2 and -2.
Diamond's got it. You guys understand where she gets the -3 from, right? Yeah, the -3 is obvious. Where does she get the 0 from?
There is
Well. Here's what she kind of looks at that. She says, "Hey, wait a second. That doesn't look like it's in the form that I'm used to seeing it, right? The way I'm used to seeing it, I'm used to seeing some kind of binomial times another binomial, right? I'm used to seeing some 2 numbers times another 2 numbers, right? So what she says is, what if we did this? What if we said this is the same as -2 times x minus 0, x plus 3.
Like that's how Jack figured it out. Possibly she could have just guessed. Like, you're just gonna go with this.
No. I think she figured it out.
Not Jack.
No. Look, Diamond says it right there because there was no other x thingy.
So they just added.
Well, I mean, okay,
That's
fine.
allowed?
John is saying you just added a 0, and then Brandy chimed in with that's allowed. All right, fine. Here, what is? All right, so we got the number 4, right? Add 0.
It's 4.
Add 0 again.
It's 4.
Subtract 0.
It's 4.
Add 0 and then subtract 0.
Okay.
I'm not
0?
changing the number.
Is it 0?
No. It's still 4, folks. I just was making sure because I didn't know. You were being sarcastic. You're just kind of being like, I don't get it. No, it's still 4. You're not I'm not changing the number. I'm not doing anything illegal here. This is a fair play. There is no fouls. There is no challenge flag on this sucker right here. It's x minus 0, and that's it. Yeah, like I used the Super Bowl reference on that. Anyway, whatever. All right. So I totally agree with you. It's at 0 or at -3. So let's say this is -3 out here. 0, 1, -1, -3. Are we cool?
Are you angry that the Broncos lost?
I wasn't
so
angry.
terribly too.
No, I wasn't angry.
They were badly beat.
I was actually, you know what? I was actually going for the Seahawks, to be honest with you.
But you said you hated their coach.
I hated their coach, I do. But Marshawn Lynch was a player at Berkeley when I was going to Berkeley as well.
Oh, so you know him?
So yeah, actually, I know him. I met him. Well,
So
I
you're
can't be like,
obligated to
I can't be
the
like,
Seahawks.
he's the last person I call before he goes to bed. You're like, how you doing, dude? Doing all right. Have a good night, bro. You know, like I met him once. He doesn't know my name, but I'm just saying, like, I'm cool with Marshawn Lynch. He's beast mode, dude. Beast mode. Anyway. And I was kind of going for the Broncos, but you know what I really wanted to see? I wanted to see a fight. I wanted to see
Everyone fighting.
no, I wanted to see a game, like I didn't want to see a sumo wrestler beat up a toddler. That's kind of what I felt like it
Yeah,
was.
it was pretty bad.
I wanted to see like 2 dudes kind of like
Not to mention
2 teams going back and forth, beating it out, like fighting for each thing, and then they were going back and forth, and the game was won by a field goal or something, you know, like this like clutch
When
thing
the
that just
overtime was like, nope.
yeah. I want to see. I love those games. Yeah. All right. Anyway, we're off topic. We need to go back on. All right. Do you guys understand how? Do you guys really understand how Diamond got 0 for it?
Yes.
All right. I'm just making sure. I guess another way she could have thought about it. She says, okay, well, if I set that equal to 0, then obviously if x equals 0, and it's being multiplied on the outside, then yeah, that's one of my zeros. We cool? Yeah? You get it? All right. Good. So x-intercepts are at 0, -3. What is the x-coordinate of the vertex? Do you understand what that question is asking?
It's pretty much the axis of symmetry.
What is the axis of symmetry? That's all it's asking.
-1.5.
-1.5, exactly. Where's the vertex at? I'm not even going to write that down. I mean, I feel like at this point you guys get it. At this point, I don't really even need to continue on with this stuff. Oh, but we're cool with this? Alright. Why don't we ask this? What's the y-intercept? What is the y-intercept? 0. Because I'm asking you, where does this thing cross at x equals 0? And you realize that there's a point where it crosses the x-axis right here at x equals 0, y equals 0. So it's not like there can be any other y-intercept. I mean, what do you want from me? It's a y-intercept right there. Alright, anyway. I think the next hard one would be maybe the next problem right there. So I'll tell you what. You have 6 problems you have to do. I'll show it to you very slowly. You tell me which one you want. I would suggest this one, station 3, because it looks to me like that 1/2 might freak you out. But let me show you and tell me which one do you want me to solve for you. All right, station 1. Okay, station 3. Here's station 3. Here's station 4. And here's station 5 and station 6. Which one do you think?
3.
3?
Sure.
All right, fine. I'm just making that suggestion just because I think that negative 1/2, that might freak you out. By the way, I'm just curious to know, looking at this, the negative 1/2, do you think that's going to cause the problem to open up or down? This is kind of a guessing game,
Down.
but kind of like a, I figured this stuff out.
Down.
Down, why?
Because negative.
Because it's negative. Very good. And Diamond's even going on and predicting that not only is it going to open down, it's going to get wider. That's what I'm thinking. And I would say, I totally agree with you. Your intuition is correct. Because you understand this. Like, this isn't magic. It makes sense. Where's the intercepts? That one's an easy question, I think.
-2,
Negative 3.
Perfect. Right here and right here. -2, -3. All right. Where's the y-intercept? That's a good question.
Is there a way?
Yeah, I'm gonna go with.
All right. What in this equation? What is r? What is the value of r? No, Raimana. What is r? There we go, -2. How did you get that? You were so smart. What's S? -3. Awesome. So, and what is A? So R is -2, S is -3, and A is -1/2. It's the stuff out in front. And Raimana, you were close. He was saying, okay, R is this number in front, but remember, the general equation is actually x minus r. So if I plugged in 2 for r, +2, it wouldn't give me this equation. Does that make sense? If I plug in -2, that negative would cancel out with this negative, and that would give me +2, and that for, whatever, blah, blah, blah. But anyway, so that's kind of where we're getting back. So what is the y-intercept? It's this multiplied together. So what is -2 times -3, which is +6, right? -1/2 of 6. What is half of 6? 3. So it's -3. So your parabola kind of looks like that. You guys agree? And then now you're expected to find the axis of symmetry and the vertex. Are we cool with this? Are we done? We good?
We're good.
All right. So you guys can do this homework. I did 2 of your problems for you. I didn't finish them all, right? I asked you to find the x-intercepts, find the coordinate of the x-coordinate of the vertex, axis of symmetry. Find what that vertex actually is, and find what the y-intercept is. But it looks to me like you guys can get this. And I also asked you to graph it. Okay? Oh, come on. It's not even that bad. Like, this homework should take you maybe about, I don't know, 6 problems, 4 problems actually. And I did the 2 hardest ones for you. I don't know. I would say it takes you maybe 10, 15 minutes, if that. We cool? You said in the homework to ask you for them. Oh, yeah. I put in the plan what these things were, but you can write them down now. Because in your packets, it's those are blank. So I put it when I put out the plan. I love you more today than yesterday. All right, let's see. Does anyone in PA speak Spanish?
No.
Okay. Because I think that if you wanted to do a song from a movie, I think that one that was stuck, the one that's stuck in my head is I would do Los Lobos version of "You Got a Friend in Me." Anyway,
I think the little kids are doing You Got a Friend, but obviously English. I think that's the stories there. Or did they do that last concert?
I think they did it last concert because it was a Toy Story theme.
Yeah.
Anyway, let's do this. So I'm just showing Diamond. Like, remember how I told you in stations? I told you here, do the stations homework, and then I'm giving you the equations that you should use. Do all problems. Station 1 is this. Station 2 is that. Station 3 and 4. So I did station 2 and 3 for you guys. We cool? Cool? Yeah? You like it? All right, good. True that. You got a friend in me. All right, here's your second homework. Actually, it's your exit pass. And here's your homework number 2. And that's it. That's it. We're done with chapter 4. I don't really think this chapter is very interesting to me anymore. I mean, like, we got it. If you want, I'll tell you what. There's 5 problems left in this homework. I think this is one homework assignment. These 2 problems and these 4 problems on the bottom, or 3 problems on the bottom. Choose one for me to solve. I'll solve one of your homework problems straight up for you. Well, I'll do it with you. I'll do it interactively. And then,
Not interactively?
Can you just do it?
Can you just do it?
well, no, I mean, that's what I do is when I do your homework, I don't actually it's not just me doing your homework. I'm actually just kind of like asking you the correct questions. So, let's see, I think I gave you, all right, so your stations homework is page, your stations homework is page, no, your stations homework is page 12 to 14. It's 12 and 14. 12 to 14. And then you also have a part of this homework, but I'm going to choose one of those. So choose a problem from page 15 to 16 and tell me which one you want me to do for you. And I'll do one of them for you. Yeah, fine. Whatever you guys want. Any problem from page 15 to me it might look good. So you can either choose problems 1, 2, or 3 from page 15, or problems 1 and 2 from page 16.
1 and 2?
1 or 2. I feel like page 15 might give you a little bit more trouble.
So then go with the 2.
All right, Romano wants page 16. That's fine.
Whichever one gives us the most trouble.
It's fine. Here, why don't you guys choose? You guys got 5 seconds. 4,
2.
3, 2, 1.
2.
All right, no, you guys just told me which page you want. I want to know which problem you want me to solve. Fine, I'll give you another 5 seconds. Ready? 5,
2 on page 15.
4, 3, 2, 1. All right. I've got 2 people who says number 2, and I've got 1 person who says number 3. And I've got 1 person who says number 1. It looks like number 2 it is. Let's do it. If we have some function, and it doesn't have a number, but it has a function that looks like f of x equals a times r, or x minus r, times x minus s. All right? Now what they're saying here is they're saying the quadratic function is a quadratic function with a being a positive number, r being a positive, and r being a positive number. So we know that this is positive and this is positive. Got it? If s is bigger than r and has a y-intercept of k, determine a possible sign of k and explain. What? What? Do you understand what the problem is?
Something about finding the sign of K.
All right.
Yeah.
Something.
You know, this is just.
Here's what I'm saying here. All right. You see how this homework, this problem set could be a little bit tougher, because it's just asking you to think of what it's asking you to do is it's asking you to kind of think of the theory behind it. All right. I don't know exactly what this graph looks like, but I do know this. I do know that it's going to cross at R and it's going to cross at S and it's going to open upwards. How do I at least know that? Tell me. And I don't know if that R is going to be over here or wherever. We haven't talked about that, but I know off the bat that it's going to open upwards.
A is positive.
A is positive. Exactly. It tells me A is positive. Right? We cool? So if A is positive, it kind of applies to those same rules. We know it's going to open up. If A is negative, it's opening down. If A is bigger than 1, then it gets smaller. If A is smaller than 1, but still positive, it gets fatter. We know those rules. They just told us A is positive. I know this thing's opening up. They also told me that R is positive. Right? So what is R going to be? If I have, so let's pretend, let's make up a one. Let's say f of x equals 3 times x minus 4. X minus s. I don't know what I know that r in this case is positive. So that means what? Oh, there we go. Diamond's answered. I'm sorry. I'm kind of looking off to the side. Diamond's fully answered it. So that means r is going to be on the right side. Do you guys agree? Do you guys see what she's saying here? Let's erase this. She's saying that it's going to open up. Okay, pencil now. All right, she's saying that r is going to be on the right-hand side. Are we cool? And this parabola is going to open up. What is s? What do we know about s?
It's going to be negative.
Do you think s is going to be negative or positive? Diamond says negative. Armando says negative. Diamond says positive now.
Well then.
Well, Diamond. Thomas is negative. You guys, I was going to say all y'all are wrong,
Now Diamond's
but
right.
now Diamond's the only one who's right. Why is it going to be positive? You tell me, folks. And Diamond, how'd you get that? How'd you figure that out? Where'd you come up with them apples? X minus s means x plus s. I'm not sure what you mean by that. Here, I'll kind of tell you why Diamond is correct. You ready? R is positive, right? S is bigger than R. If S is bigger than R, then S must be positive as well. In fact, more positive than what R is.
I got you.
Gets me?
I got you.
That's it. That's all. That was the logic there. All right. So S could be any number over here. It could be over here or wherever. But I mean, we know that this is R and this is S. And we know that this problem is going to open up, right? And I'm asking you to tell me whether K is positive or negative.
It's positive.
It's positive. Are you sure? You should say I'm positive. Why? How do you get it? Because we know it opens up and know it crosses over there. It must be positive. It's got to be positive. It can't be negative. How can it be negative? If it were negative, it would be open down. I'm positive it's positive. That's what Diamond says. Or Raimana, or Diamond. What did Diamond? Diamana?
Did you just give them a ship name?
What?
A ship name.
Oh, is that what they're called?
Yes. Like in TV shows or movies or actresses, for example, Brangelina, you morph their names together.
Oh. You know what? My name is Tosh, and my wife's name is Tasha.
Ha! You guys don't have
So
a
we
ship
would
name,
be-
you have one of those ones.
Tosh.
Yeah.
Oh.
I have my friend whose name is Ashley and her boyfriend's name is Ashton, and I'm like, you guys don't have one.
Yeah,
Or
anyway.
it could be Dasha.
Alright. Dasha?
Because doll day. You can morph last names too, or first and last names.
Well, our last names are the same too. What do you
What?
want from us? Yes, me and my wife had the same last name.
Yeah, I mean, I'm talking
We
about
didn't have the same last name
Have
before we were married, but after we were married, we had the same last name. It'd be a little weird. I think there's laws against that. If we had the same last name before we were married, but I'm just letting you know. I mean, like, I'm sure that if you happen to meet somebody else named Dalday that wasn't related to you, but then again, Dalday, we're the only Daldays in the phone book on the island, so it's getting a little freaky there, folks.
The only
All right.
doll day?
Anyway. Yeah. Alright, are we good? Did you guys understand where that logic came from? So therefore K must be positive. So that's what you could say. Do you see how we logic our way through that thing? So there's no numbers involved with that thing, but we, you know. Are we cool? Alright. That's it. I'm done. I don't really know what else to do. Class is over.